Find the answers to questions you may or may not have asked yourself here at Kaleidoscience, Conversations on Cognitive Science, hosted by Elisa Palmer and Sönke Löw.
In today's episode, we are finally going to talk about the GPT. So we already hinted at the fact in several sessions. So it is basically an artificial intelligence, and it is very popular right now in the public discourse, especially like I think everybody has heard right now of ChatGPT, and today's guest will or has done something with the basic model behind it, and we are finally going to talk about this. Speaking of today's guest, we have today here Konstantin Strömel. Welcome.
Thank you. Thanks for having me.
And as always, we like to play a short game at the beginning of each episode and to get to know our guest a little bit. And we would like you to complete these 5 sentences. And the first one is, as a kid, I always wanted to be.
Ooh. Either policeman or firefighter.
Ah, the classics.
Yeah.
If I was an emoji, I would be.
Ooh. The smiling emoji with the triangles as eyes. I think that's the one I use the most.
Yeah. My favorite thing to do on the day off is
reading, cooking, and spending time outdoors. Yeah.
Nice. The fourth one. Right now, I'm most fascinated by.
Oh, that's a tough one. Well, I guess generative AI is one of them. I guess in general, the whole field of natural language processing we're going to talk about today. Yeah.
Yes, we definitely will. And the last one, I know it's time to call it a day when.
When I fall asleep while reading, when your eyes are getting heavier and heavier. Yeah.
It's in a way when normal human beings stop functioning. As we already hinted a bit, you are also studying in Osnabrück. Where in your studies are you at right now?
Yeah. So I started my bachelor's here in 2019. So I'm at the very end of my bachelor's degree. So basically did all the coursework and exams and so on. I just need to wrap up and write the thesis.
And during your studies, what were your main fields of interest? Was it always natural language processing or did it change?
So when I started studying, or in the beginning, I was really open to everything. So I just took, all the basic introductory courses. But I would say the field that I was most interested in were, AI, artificial intelligence, computational linguistics, but also a few of the philosophy classes, especially philosophy of language or language and cognition. Yeah.
So it was always quite language focused for you.
I guess so, yeah.
And how did you come to the area of natural language processing in the end? So was it just by coincidence or did you stumble upon it and were like, wow, that's really something I want to do?
Yeah. Well, I guess first of all through some of the classes here, for example, the first iteration of deep learning for natural language processing, but also some researchers in the field. Example, Richter is like one of the guys that is behind this whole concept of deep learning for NLP, and he's a really inspiring character. Yeah. And I would say in general, in AI or in the machine learning field, it's like all about numbers and math and so on. And I feel like if you use it on language, there's like another layer of interpretation that you can use. Like you can just read the output and you understand what's happening more than if you just look at like a classification or a probability that, for example, in computer vision, something belongs to this class or the other one.
Yes.
Yeah. So I like that aspect.
Speaking of this part, like if I was a child, how would you explain natural language processing? Because I feel like many people talk about ChatGPT and similar things, or maybe also use DeepL or Google Translate as the very first or very, very early translator. But if you would explain NLP or natural language processing, how would you do that in simple terms?
Yeah. So, I mean, I guess we can just break down the term. So, natural language basically means any language that humans use to communicate. So, for example, German or English. Also, sign language is a natural language. So that, well, you might ask, what other languages are there that are not used for, for communicating in a way? But, for example, a programming language would be a different type or kind of language. And then processing basically means that the computer kind of understands this language or can also generate it and understand it. So they actually, this whole field of NLP, natural language processing, are also generation, understanding, and it's just all combined in this one big term, NLP. Yeah.
So natural languages are all languages that I use. So I was just thinking why you said what other languages might not be used. For me, that would, for example, be Latin. But like Latin used to be a natural language, but isn't anymore. But I guess unnatural languages are all languages which, well, in a way exist, but you wouldn't use them on a day-to-day basis.
Well, I guess one could argue that Latin is also still a natural language. It's just not really like spoken anymore. But in general, there are quite a few languages that are, for example, not really written at all. So they're just oral languages, but you can also use them in NLP. Or I think it's still like a property of language doesn't have to be, you need to write it down and read it. But
so also audio language could be interpreted. Okay.
Yeah.
You already mentioned previously the seminar that you took here at the university, or one of the seminars you took at the university. And our guests always have like a project they are working on. And the project that we want to talk about, that we got in contact about, you did in the scope of one of the seminars, is that right?
Yeah, exactly. Yeah. So it was a seminar about advanced natural language processing. And we developed an application there, and this was now turned into a plugin for StudIP, so the learning management system we use at our university.
Okay, can you maybe run us through like the initial idea? What was the thing that you wanted to achieve, and maybe how did you came up with that?
So the very first idea that we had was, I guess most of you know index cards or Anki decks, which are the digital version of it for studying for an exam, for example. And well, it's very time consuming and tedious to actually create these cards. So you have to think of good questions and then answer them and then use them for learning. And we thought, well, why don't we ask a language model to create these questions for us? Because then it's also just a lot more variety, because we can create basically an infinite amount of questions about one topic. And while doing that, we also just discovered or had this idea, well, why don't we also ask it for feedback, which is something you can't do with index cards, right? You either know the answer or you don't, and then you look at the sample solution and then you're like, I forgot this part or that part, but it doesn't really explain that to you. And that's the basic concept behind it. And in the very first prototype or web application, you really just specify the topic, for example, gardening or neurobiology, something like that, and it would ask you a question about it. Yeah.
So the idea is to create a learning assistant to support students or generally learning by using input that you give the system and automatically create questions out of it, right?
Yeah, exactly. So so now we integrated this, as I said, into this learning management system. So where you find the courseware with all the contents of our lectures, or especially the online lectures, and this is a lot more specific. So you only want questions about a certain topic or certain part of a lecture, and for that you really need to provide a lot more context. So the model really knows what kind of question it should ask and about which topic actually. So it's a bit more specific now.
For people who are not really into that field, they probably don't understand the scope of what you're trying to do, and maybe they think like natural language processing is so easy for humans. Maybe it's for the computer just the same, but can you explain to us like if the field is really challenging for computers or not, and what maybe the solutions are you opted for, because you obviously found a way to create natural language questions and extract the answers from somewhere.
Yeah. Yeah, so I mean, you already hinted on GPT or ChatGPT. I think probably, you both use it before. Also, most of the listeners have probably, used it. And so GPT stands for Generative Pre-trained Transformer. So generative means, it generates something, text in this case. Pre-trained means it's a so-called foundation model, so it's trained on a really huge amount of text. You can think of basically like the whole internet and every book that's been written, like a simplified term.
I actually got the numbers.
Okay.
For ChatGPT, it was trained on 345 million parameters of conversation data. And GPT-3, which is kind of the basis, as when I'm not much mistaken, for ChatGPT, GPT-3 was trained on 175 billions of parameters of websites and books. So it's quite a large number. I tried to find a comparable number somewhere, and I was like, I didn't really get any results.
Yeah. And so the last part is a transformer, which is just a type of network. So you use you basically encode some text and then you decode it again. And what really changed this field in the last 2 years is that we just have a lot more compute power available. So they were just able to train really huge models, and scaling it up really increased the capabilities of these so-called language models or large language models.
Something that was often really challenging for me to understand was how encoding and decoding works in an algorithm. Can you simplify that in terms?
So well, if you think of a normal sentence that you use in natural language, so basically for the model to really make any sense of it or use it, you have to break it down in smaller parts. So you could think of maybe I just used a single word in a sentence, but in these models they use so-called tokens. So that's usually around 3 letters, a bit like a syllable. But also if it's a very complicated word or unknown word, then it could be really just single letters that are combined. And what was the exact question again?
How would you explain encoding and decoding in simple terms?
Yeah.
So encoding and decoding of a sentence, for example, when I give the sentence, I went to the supermarket. How would it understand that it was me as a person who went to the supermarket? How would it know that I went to the supermarket? So how would an algorithm make sense out of a sentence, which is quite simply understood by human beings?
So the thing is, it also depends on like the task you want to give it or the question. So in general, in this encoding part, it maybe one easy way to think of it would be it needs some kind of representation of order or of time. Like when you feed in a long text, it should still remember what was said in the beginning of the text. And if you ask a question at the very end, that could be answered by just reading the first sentence. It should somehow keep this information, but it's a bit tricky to simplify it that much. But I think maybe an easier example would be if you use machine translation. So you have a sentence in English, for example, that you encode, and then you want to have the sentence translated into French or German, whatever. And in this decoding step, it kind of needs to find out the important information. So not only what each word means in another language, but also like the relations between subject and object and so on, to really make sure that it kind of understands it. Yeah.
So it's not sufficient to just understand the words, but you have to understand the meaning of a whole text or sentence in order to, well, use it for other processes.
Maybe one example I can think of is like in Star Wars, there's this Yoda character, and he always formulates like wrong sentences to us, but we still understand what he means. So if you do like the same thing with like a translation, so you have like a different sentence or like a different language, and you have the same sentence. But if you would just translate it like word for word, and then there could be like some confusion, and in the end you get out this wrong sentence, but you still understand what it says. And the model then has like another way of formulating proper sentences from this nonsense speak.
Mm-hmm. Yeah. So maybe to get a sense for how this model is actually trained, or that I think that also illustrates it a bit, or it's easier to understand than talking about encoding and decoding, and there are like a lot of different layers where they basically extract this information to find that out. But one very basic step that is used to train these basic language models is so-called masking. So you take an input text and you just kind of cut out certain parts of a sentence and just replace them with a mask. And then the task of the model is to predict this word. So it's a bit like as you might remember from elementary school, you have a worksheet and there are some gaps missing and you need to write the correct word. It's basically doing that. And because it also, it has the training data to compare it to, so the actual text, it can just look it up and see if it is correct or not, and then adjust some parameters to get really good at this task. But then there's another layer that you put on top of that, which is, you fine-tune the model on some instructions, for example. So you give it a task that it should do, and you get the result, and then you can, for example, rank the very good texts that were generated or flag some other texts that are bad or that you don't want, and feed that back into the model, and it will adjust its internal processes a bit to generate better and better text.
So that's, in a way, the learning process a model undergoes.
Mm-hmm. Yeah. So you have this basic model that can basically just always predict the next word that makes sense to generate the text. But then you also need to fine-tune it on some instructions and using actual humans that read these texts to say, okay, this is really a good text that answers this question, or is like the desired output for this description or task. And then it also uses this data to just improve.
Maybe there's one thing that I currently imagine, because coming back to the model you used and the purpose you used it for.
Mm-hmm.
So one thing that is often said when someone gives like an input or wants some knowledge output from ChatGPT and it basically makes up something, then the argument is always, it's like basically autocomplete on steroids. So you just like predict some sentences that looks good but doesn't have any content, but you found a way to fill the actual content of the lecture into that model, right?
Mm-hmm. So yeah, I guess what you said or hinted on is that these very basic models, they're really just a bit like autocomplete, yeah. So they, for example, if you type in the beginning of a sentence or a story in the OpenAI GPT playground, it will just like keep on spinning and develop a story. But as you said, the work that we put in, or our main contribution in a sense, is to design or engineer the prompt in a way. So a prompt is like an instruction that you give to a language model to generate to shape the output that you want to get. So it could be an instruction, or it could be some examples, or just a question, something like that. And then it generates text based on this prompt. And in this sense, you kind of have to set up the stage to give the model a sense of what it's actually supposed to do. And you can do that in a very detailed way. And also, for example, in this case, if you want to create a question about a specific topic in a lecture, then you can feed in some parts of maybe a transcript of the lecture video or some text documents, stuff like that, just so the model gets some context and knows what it actually should ask. So you're not asking the model just create a question about, I don't know, reinforcement learning for me, but you actually give it quite a lot of context, and then it will use this context to generate meaningful questions. Yeah.
So in a way, it's extracting information from a text input to create questions.
Well, it has, as we already talked about, this huge amount of training data that it was trained on. So it has some kind of, well, it's really hard to call it knowledge. It's like a basic understanding of a topic, for example. So if you ask it to explain this and that to me, it can usually do that. Mm-hmm. But if you ask a very specific question, then it might just start to, as you already said, to hallucinate. So it's still very confident that it knows what the good answer to this looks like or is structured and so on. And it also, well, it's very coherent and it makes sense, but it's just not correct. Yes. So it will just make something up that is very plausible, but not actually the content. Yeah.
If you play around with ChatGPT a bit, you can also make up papers and scientists, and it all sounds super sound. But I've once asked ChatGPT to give me I've just been like playing around a bit. I was like, can you write me an essay about this specific topic and also give the references? And it was like making up 3 papers, and the authors existed, and also in the roughly right topic. But the papers and the combination of authors didn't exist. It was like, thanks ChatGPT, but no.
Yeah. Yeah.
You are using GPT-3 as basement, right?
At the moment, yeah, because it has a lower latency, so it just reacts very fast. And because we have this interactive application, we really wanted to generate these questions in real time and the feedback. And so you don't really want to press on the button and then wait for a minute and then get a question. It would kind of destroy the user experience a bit.
Maybe really quickly, because we talked about that those models exist, but what is GPT-3 like?
Yeah, so it's it's kind of the 3rd version. So there was the basic GPT model, GPT-2, now GPT-3, and the model behind ChatGPT is GPT 3.5 or 3.5 Turbo. And now we already have GPT-4, which is, you hinted about the parameters used to train these models. And GPT-4 is another step up, so it really just has a lot more parameters.
Yes.
And therefore also more capabilities.
Maybe one quick hint, like everybody could in theory create such a model, but the first of all, the amount of training data is very hard to achieve, and also the amount of computational power, as you hinted at earlier, that that really is like that what drives us forward. And so basically the company behind all those GPT models is called OpenAI, and that's like a single company, and they are like the market leader in this region, more or less.
Well, I mean, there are also a lot of other providers of also very capable large language models. But as you said, the compute power you need to train these models, or just the costs for electricity, for example, are really enormous. So OpenAI has some kind of partnership with Microsoft, so they provide lots of infrastructure for them to train these models or to run them now. And I think just training GPT 3.5 or 4, we're talking about around $5 million just for electricity to run the servers or the GPUs to train such a model, and then to also keep it up and let people use it in such a big scale. I mean, we're talking about hundreds of millions of users. I think that already costs them around $500,000 just per day to keep this whole thing up. Yeah, so it's really you can't do that as just a single person or little research lab.
You couldn't do that in your seminar now.
Something I was thinking about, because you mentioned that there are several different versions of GPT already. So you're using GPT-3, but there's already GPT-4, and ChatGPT is based on GPT 3.5 something. I've heard that ChatGPT is performing better or worse depending on how far they change the model behind it, or the learning parameters. Is that the same for GPT-3, or is that kind of a finished model? There are different versions of the single model, so that always depends on, again, the size of the parameters. And there you can really see a difference between the ones with more parameters are just more capable. But for certain tasks, you don't really, it's a bit like a overkill to run a really large model to just create, some very easy task. And if you definitely can see a difference between larger models and also older models and newer models. Yeah.
There has been some talk lately that ChatGPT is performing worse over time because there are attempts at going around the rules that OpenAI sets for this, and they have to enforce the rules, and that decreases the performance somehow. Have you, in your project, noticed anything that the performance is decreasing, or is it for you like a constant model?
So for us, it's pretty constant so far, but what you were talking about, that the performance dropped over time through interaction with users, I think it is because it also takes into account the kind of prompts or the instructions that you feed into it, or you can also rank some answers and so on, and this information will be used to improve the model again. But in a sense, if these are like very bad instructions or bad ratings for good answers, good ratings for bad answers and so on, to simplify it a lot, then that can actually decrease the performance of the model. Yeah.
Just coming back to your learning assistant. Well, when we think future-wise, would you think that, or would you say that learning assistants in the way you created it are going to be really important, or do you think it's just something really recent which will kind of get lost in the future again?
Mm-hmm. So I think they really have a lot of potential. I mean, if you think of the way a normal lecture or maybe an online lecture is structured, at our seminar, for example, you usually have maybe 1 or 2 teaching assistants or tutors, and then you'll have the person that teaches the class. But so these are very limited resources, right? If you might have this VIPS question page, but if you post an open question in there, it's just in the class with 100 or 150 people, it's just so much work to read these answers and grade them or give them some explanations.
Just quickly jumping in for all non-students, WIPS is kind of a tool our university used to make questionnaires where you can answer multiple choice questions or open questions. And the open questions are really hard to grade sometimes because you have to read them all, and for that the assistant could be a help.
Yeah, exactly. So it could basically take that part away, or that workload away from the teaching stuff. And at the same time, I feel like this is the part where you actually understand or realize if you really understand the topic. So if it asks you to explain this and that term, or what does, if we're talking about code, then it will ask you what's the purpose of this function or this variable? What does it change? Why do you use it? And if it's just a multiple choice question, like the way you approach it is usually 2 or maybe all of them don't really make sense except for one, and so you just click that, but you don't really understand why exactly it is like that. And so I feel like this interaction is really important to learn something. So to explain it to a peer that you're studying with, or to get an explanation and find out where you maybe misunderstood something, so on. And that's something that, well, if these models work well enough, then there's a lot of potential there. Or, for example, you might know Khan Academy. It's in the United States a very large network that provides some educational resources, like free teaching videos and materials and so on, where you can prepare for the different bar exams or high school exams, college stuff in the States. And they also have a partnership with OpenAI and use an intelligent tutoring system that they call Kanmigo. And maybe you should look it up. There are some cool videos where you can see how it is used, because it's basically really like a personalized teaching assistant or tutor, where you get, for example, a math question or task, and you can ask it and say, I have no idea what I should do, how can I solve it? And instead of just telling you the answer, which would be the way when you just type it in some kind of calculator, it will basically break down the task for you, or tell you, have you thought of doing this and that? Or maybe the first step could be doing this, and then you can do that step. If you have some mistakes, it will explain why this is wrong, but all without just giving you the answer. It's more about guiding you through this whole process of understanding a task and understanding a topic.
It's basically normal tutor jobs.
Yeah, exactly.
Yes.
Yeah. But I mean, the thing with tutoring is that it's very expensive. Like only a small amount of people can actually afford a personal teacher or tutor for their kids. And again, it's a matter of limited time, right? And also limited. In a classroom with maybe 30 people, there might be 5 people that already understand the topic really well and they get bored, and 5 people that miss some kind of basics that they would need to repeat first before they go into some more advanced stuff. And this tutor could provide help for both of the groups. So it could adjust the tasks and make them more difficult for the people that are already a bit more ahead, but also help the ones that have some gaps in their knowledge to get back on track and like level out.
Yeah, but that it would also individualize the learning experience quite a lot, because it would be more focused on the level of knowledge a student has or a person has, and be less on, well, we have to learn this amount in this time, but be more like, well, you're still missing this bit, so we first should work on that part and then go to the next part to support each individual better at learning.
Yeah.
Do you also think there are any downsides or risks in using these kinds of tools?
Yeah. No, definitely. I mean, we already talked about hallucination, and that especially in some knowledge domains, it might not work that well. And that's really important. Or in general, like what we try, or our idea behind implementing and using these tools is not to replace the teaching stuff. So we don't want to say, we don't need humans anymore. The AI will just teach everything and like take over. But it's more really just a tool that you can use to improve and to make sure that you really understand the topic. And this will just free up a lot of time and resources for the teaching staff to, maybe be able to provide some more individualized content and so
on. I don't know how well we will hear that in the audio, but the university is under construction. And, well, I had the pleasure to watch a guy working on the lights outside of the window, so it was quite entertaining.
Yeah.
Because cognitive science is encompasses so many different fields, we always like to get the perspective and maybe of the people they bring to the project. So we already talked about what your main fields of interest are. Do you think like all these came together in your project? So what are the main fields of cognitive science traditionally that worked into your project?
Well, so I guess the main fields are, one side, computational linguistics in combination with artificial intelligence or machine learning. But in a sense, it's also like when you create an application, it's also a lot about the people that will actually use it. So it has some kind of human-computer interaction aspect or user design, user experience part. And in this case, it's interesting because, I mean, we're talking about education and learning. And I feel like as a student or, as a young person in university, you actually have quite a bit of knowledge about learning, maybe not the theoretical, didactic theories and so on. But I mean, you went to school for 12 or 13 years and then to university for a few years. So like a main part of your life has been in an educational system and it's been about learning. So in a sense, it was easy for us to take the role of a student or user because we're just students ourselves. So we can implement some features and then we know if they are helpful for us or if they make sense. And that's why it was easy to test some functionalities.
And at the end of each episode, we want to have a short summary or take home message, and maybe you can also again talk about how you started it, and you didn't start it alone, correct? So maybe just give us one short recap of how you got to the idea and what you did and maybe what your future is.
Yeah, exactly. So it was a project with two other people, so Melich and Max. And me, we sketched up this whole idea of the application. Then Melich and Max did most of the programming and built the web page, and I created the prompt. So we just worked together and developed this whole concept. And then we approached Tobias Thelen, who was the head of the Center for digital teaching at that time. And he was really interested in it. And he offered us to use one of his lectures or classes as a kind of testing ground to actually use it with students, or with a large amount of students. And so we developed this plugin for StudIP and tested it in his lecture with around 100 or 120 students, and also asked them for some feedback through some feedback forms and so on. And in general, it was really positive, so people liked it a lot and thought it's a valuable resource for learning. So now this next step will be to find more professors that are interested, and also we want to test it in different kind of subjects and domains, because it shouldn't be only for like technical people and classes, but also maybe biology, psychology, or it would be interesting for me personally if it also works well with history or some subjects that are really but it's very important where you get information from, and sources are like the whole concept history is based upon pretty much. So that might be a bit challenging, but yeah, we'll see.
All right, then thank you very much for being here today, and I'll be excited to see if I get to use the tool maybe in the future in some course.
Yeah, right. So yeah, maybe one day it will be like a university-wide feature that everybody can use. That would be very cool, yeah.
Indeed.
Thanks very much.
Thank you.
Before we roll the credits, we'd like to inform you about the Coxie Space Day. This is an event happening on the 18th of November 2023. On the Coxie Space Day, you can meet us as the makers of the podcast, but also connect to other fellow cognitive science students and alumni. There will be a lot of different booths, fun workshops, and some exciting surprises. The Coxie Space Day will be the perfect spot to get in touch, connect, and find orientation in the whole universe of possibilities in cognitive science. You can register on www.coxiespace.de, that's COGSCISPACE.de. We hope to see you there. When you enjoy listening to us, the best way to support us is by following us on your chosen podcast app. This could either be Google Podcast, Spotify, or Apple Podcast. Another good way to support us is by following our Instagram account, which is called kaleidoscience_pod. On our Instagram account, you will also get regular information on the next episode. Thanks a lot for supporting us. This was Kaleidoscience, hosted by Elisa Palme and Sönke Löw. Produced by Alina Ohnesorge, Elisa Palme, Sönke Löw and Sophie Kühne. Produced in collaboration with the Cognitive Science Student Journal. The music was produced by Jan-Luca Schröder. The logo was designed by Annika Richter. Thank you for listening and joining us on our journey through conversations on cognitive science.